Thanks. Okay, my name is Claudio Giorgi from JOK company. I'm in charge for development and maintenance of precipitation products for the HSAF. Thank you everybody for being here. Let's have a summary of the things we are talking about today. First, a summary of the HSAF products related to rainfall. How to get access to the data, both for short-term and long-term data, which kind of formats we are using now and what is going on in the future, some suggestion about the procedures to transform the data in Matlab readable formats, and then a few examples of plotting in a specific area of interest. Let's start with the first item. Which are the HSAF products related to rainfall? There are, first of all, 4 categories of products. The operational products, in this case H01, 2B, 3B, and 5B, which passed completely the process of from the very beginning, from the theoretical idea to the final position. Pre-operational, which are 15 and 18, which in some way had not completed the process, but anyway they are working at the same level of operational ones. Development products that are not yet available, but maybe they are coming soon. Demonstrational, so they are in use only for testing purposes, not available to anybody. And auxiliary products, which are not useful as themselves, but we consider more or less at the same level as the operational ones, and they are 17, 20, and 23. Just to give a, I hope, a clearer idea of what these numbers mean, we see now the 5 products related to the microwave scanners for the low Earth orbit satellites. They can work both from conical scanners and cross-track scanners, and usually we have a full orbit available in something like 1 hour and a half or maybe a bit more, and all of them are operational, completely operational. Usually they are available at the full disk resolution, meaning that full disk is the view of the Meteosat second generation, while the H20, the last, has a global display, which refers to the full 360 degrees of the Earth. These are examples of the plots we do continuously for H01, H02B, 17, 18, and 20, that is for the full globe. Please note that these plots are not really uniform in format, and one of the things we are working on is to present the results in a more uniform display in terms of scale, in terms of kind of chart, and so on. This should be done in the next months. The second group of products are the ones obtained by blending data from the low Earth satellites with the infrared 10.8 channel from Meteosat second generation. So we have some kind of algorithm. There will be an explanation tomorrow morning by Davide Melfi about this. And as for now, we have 2 operational products, H03B and H15. 15 is the oldest product we have now. It is still pre-operational because it's going to be replaced, and is the only remaining product displaying only in the European area, while H03 are available for a full disk display. Since these products are related to the Meteosat images, they are produced every 15 minutes with the same time scan of the Meteosat. These are two pictures for H03B and H15. As I told you before, 15 is the only one presented in the European area until now. The third category of product is the one who considers the total precipitation, both in accumulated values or daily mean values. Now, in this list of products, we have the H5B and H23. Both of them are working continuously. H05 is available every 3 hours, which means at 0, 3, 6, 12, and so on during the day, having a total amount of rain spent for 3, 6, 12, or 24 hours. H23 instead is a regular grid product working only once a day, having the total amount of rain captured in the full day of reference. These are the two examples for the products I described to you. And now I think it's useful to have some picture of the dependencies of the products one from each other. On the top you have the low Earth orbit satellites products 1 to B, 17, 18, and 20. On the left side we have the products related to the Meteosat information, which means infrared channel, the products from nowcasting SAF, which are the cloud type and the cloud height, and Nephodina, which is a product where you can find the location of convection cells. H01 and 2B are mixed together with the MSG to produce the product number 3, and its total is product number 5. 1 and 2 again are used together with Nephodina to create H15. And last in this picture, 1 and 2 are mixed together to create the 23. The 23 is the same product that Luca introduced in his presentation a few minutes ago. This is the list of the products we are presenting now, but there are many more things in the near future and in the long-term future. First, in the near future, we are going to integrate all the data from microwaves in a single product that is H68. It's available every half an hour, and the total from 68 will be 67, that is available at synoptic time, which means 0, 6, 12, and 18, adding up for the full 24 hours of one day. We already have test cases for more than 1 year for 68 and 67, so we are going to pass this data to the test team, and as soon as the test will be passed, these products will be available to the public. In the midterm, we are working to another couple of products, which are 60 and 61. 60 will mix all data from microwaves and all data from images in Meteosat second generation, having 15 minutes time for delivery, and having 61 every hour, giving the total for the preceding hour. Other products are also in development. They are not presented in this slide. Just one mention to the long-term future, because as you can see, all these things are related to Meteosat second generation with a resolution of 3,312 pixels and 15 minutes time of delivery. The products for the Meteosat third generation are already available and running with simulated data, of course. They will have 5,568 pixels and 10 minutes delay, but of course we need that the satellite will be flying before having them. Documentation. For all the products I listed here, you have three kinds of documents. The product user manual, a manual having the theoretical approach to the algorithm used, and the report about the product validation. All these documents are available through the HSAF website. This is hsaf.meteom.it. It is going to change its face, so I show you what is going to work in the next few days. All the following slides will refer to the new format of the site. How to get access to the data? First, you need to register in the website using the link that I showed in this picture. You select new user, you need to fill the usual form, send the form, receive an email with a link to activate the account, and in a few minutes you will be able to access the data. There are two ways for having access. One is to use the FTP client, any of the clients you prefer, through the server ftp-hsaf.meteom.it or the website itself. For data which are within 2 months, 60 days, you have access without any limit both to the data and to the pictures. For older data, I mean more than 2 months, you can fill a form for having a download for the product and for the time of your interest, and the form is available through the website. Here we have the picture of the website, how to download products, and how the products appear through FTP client. As you can see, for each product there are more than one folder, depending on what you are looking for. For example, the data or the pictures. A few things more is coming in the next pictures. Which are the data formats we are using and where we are going on? Well, about data, we use buffer, grib, and netcdf, usually in gzip compressed files. Pictures in a PNG file, which are not available for data older than 2 months. And only for H15, the quality of the data is not written inside the data itself, but in a separate file. All the file names always have some rule to help identifying. First, the name of product. Second, the day and time reference, usually in the form year, month, day, hour, and minute. Only for H02B there are also the seconds. And sometimes there are other information. For example, here we have this H02 product was obtained from Matlab satellite with the number 42575 orbit. In the last example, the 12 here represents that the total amount of precipitation of H05B at the 1st of December, 12 o'clock, is referred to 12 hours adding up. This is a summary of all the products I mentioned with the example of the name which you can find over the FTP web server and the format we are using. As you can see, only H01 and 2B are still using the buffer format. Actually, we are giving both buffer and netcdf files, and the buffer format is going to be discontinued in 2 months. So within 2 months, we are going to have only grid files and netcdf files. Of course, buffer files will be still in use for older products if you need to download something coming from the past. Since HSAF is a set of growing products in constant evolution, we have both new products that are going to disappear, file formats that are changing. So in this continuously changing environment, we suggest to point to netcdf file formats that will be the future for this work. The grid files, which are in use for H03B, 15, and 5B, will still remain in use only until these products will be working. In the midterm, they will be discontinued. So we suggest to refer to netcdf file format. For sure you know it, but anyway, this is the link to the site for all the details about netcdf. Maybe that somebody already is using the process based on buffer files, so we still have an utility available through the FTP HSAF.it at the directory utility netcdf to buffer for converting NC files to buffer files. Some suggestion for changing the data in the several formats. The 3 formats, buffer, grib, and netcdf. The first 2, buffer and grib, were recommended by World Meteorological Organization, but the third is much widely used in scientific laboratories, so we are moving to netcdf to be more user-friendly. The utilities, anyway, are available both for buffer and grib, and another one I will suggest you for grib files too. First utility comes from ECMWF website. It is EC-Codes. EC-Codes prepares an application programming interface which can read grib and buffer files. You can find it at the website showed at the bottom of this slide. This is the website, and you need to download all the files and install on your computer. It's not very easy to use, so if you are not interested in buffer files, maybe you do not need it. On the other hand, wgrib2 is another software utility which is free, available from NOAA, CPC, available for any kind of usual operating system. Only a few minutes to have it up and running, so I suggest you to use it if you are interested in grib files. This is the link to the source. This is the web page. And if you download wgrib2, you have only 3 steps for converting a grib file to a text file. First, you you dump the grib file to an intermediate file, which all the columns contained in the original grib file. Second, you can select the columns of interest. In this case, we are selecting the column 5, 6, and 7 to have latitude, longitude, and rain rate. Since rain rate is expressed in millimeters per second, here we are multiplying by 3,600 for having millimeters per hour. And doing this, we have a shorter form of the dump with an extra line at the beginning using simply said for discharging the first line. Finally, we have the final text file containing the data from the grid, as in this example, for example. What to do to plot? Well, I think here we have all the utilities we can think. First, please follow the red paths. These are the paths we are actually using within the automated process. Starting from buffer, grib, or netcdf, we always convert to text files. Then using the generic mapping tool, we have the PNG files. These are the normal procedure for us, but which is quite easy to do for, how to say, recurrent operation. But if you need to do something which is more specialized to do something, it is not a good solution. Here we are listing also the EC codes utilities for changing buffer and grib to txt, or wgrib2 for changing grib to txt. I suppose that most of you will use Matlab, but anyway, Matlab can read the netcdf files as in a native form. But anyway, I will mention also two more products. First of all, let's take a look to the last one, Panoply. Panoply is a simple tool available for free from the NESA website. It's very useful for having a quick look to the data, because Panoply will show you the content of the file, and a very simple procedure to have a plot. In 2 clicks, you can have the picture of what is going on. The limit is that you cannot specify much more than this, so it's useful for having a quick look, but if you need something more detailed in a specific area, it's not enough. So the other resources we can use are generic mapping tools, as I told you before, or general purpose languages. I will not speak anymore about this, Matlab, or MacIDAS-V. Okay, now I present you 2 Matlab scripts for creating PNG files from netcdf or text sources. They are quite the same. This is the first one. This one is starting from an H20 netcdf file, and only 3 lines of code are needed for reading data. All the following lines are the adaptation of the data to the Matlab matrices, and then the commands for plotting. Using only these few lines, you will have this picture coming from H20. This is a pass of the satellite of November 28th. In that day, there was a flooding in the Isle of Sardinia. And this is the plot obtained exactly by the same example, only changing the limits of latitude and longitude in this line to have a close-up view of what happened. Actually, the satellite passes over the Sardinia 1 hour later than the flooding happened, and this is what happened in the town of Bitti. There were 3 casualties. If you are starting from a text file, the program is more or less the same, because the only thing that changes are the 4 lines, before there are 3 of them, the 4 lines for reading the data, and all the other things are exactly the same for obtaining, for example, this picture from an H01 satellite product. These 2 examples are available through the server, and they are called plot_nc and plot_txt.m. The last utility I suggest you is MacIDAS-V, which is a free open source visualization and data analysis software coming from the University of Wisconsin. Can be used under Microsoft, Linux, iOS. This is the site where you can find it for downloading. And really in a few minutes you have this kind of product running on your computer. Well, after all of these rain products, I think we need some Rainbow. I thank you for your attention. This is the address for having support. User support _HSAF at meteom.it. Thank you, and I'm waiting for questions if there are any.